So in the previous session, we started on what is Snowflake, and we went through how you can create your Snowflake trial account. So I believe like you should have already created your Snowflake trial account. So today we are going to see about the architecture of Snowflake. So how it is different than other data warehouse systems. So Snowflake architecture is important to understand. That helps you to visualize a lot of things, how the data is getting stored, how it is scalable. So the architecture plays a key role in understanding a lot of internal concepts here. So we are going to see that in detail. Okay, today we are going to discuss about Snowflake architecture, and then we are going through Snowsite, the web UI. So we are going to see what is web UI, how you can use the web UI, and what are the sections are here. We are going to see that. Then we will see in your local how you can use Visual Studio Code, run your SQL, and how we are going to use local setup. We are going to see that. So, and I'll also tell you what are the software you need to have it in local, and what are the software you have to need to install in your local. I'll explain that step by step. So these are the things we are going to cover today. So first, let us start with the architecture. So before starting with the architecture, so in the previous session, we discussed about Snowflake is a cloud-based data warehouse system. Okay, so what is the purpose of Snowflake? So what is the purpose of data warehouse? Collecting data from different sources, bring it to a centralized area. Okay, so I'm collecting data from my organization, different source systems, bring it to the centralized system. That is what your data warehouse purpose is, like collecting from multiple sources. So you are collecting from multiple sources, doing ingestion and bringing to the centralized system in my Snowflake. So I have the data in different forms, raw data, transformed data. So I'm creating data in table format. Okay. So in my Snowflake, I'm storing the data in table format. So that data can be used by consumers for different purposes. For visualization, data sharing, data science. So your Snowflake, you are storing the data in table format. You are going to store the data in table format. So here we already have Snowflake trial version. So we need to create tables and do the ingestion. That means collect the data, store it into Snowflake. So that is what we are going to do. So here, how it is integrated with the cloud, how it is storing the data, where the data is stored, and how, what is warehouse, why we need warehouse. So we are going to discuss about all this thing. So let me go to the Okay. So as I said before, you cannot run Snowflake on on-premises. You need cloud account. You need AWS, Azure, or GCP. So it's a cloud native data warehouse system. And in Snowflake, you are going to write SQL. You are going to write standard SQLs. You are going to write DDL or DML. You are going to create tables, create database, create views. So you are going to do SQL functionalities. You are going to write aggregation queries, windowing queries, like different kind of store procedures. So you are going to write SQL queries in Snowflake and store the data. And consumers are going to access the tables, views, aggregated queries, and use the write SQLs and access the data. So that is how your data warehouse is going to be used. It's a storage system. It's a storage system where it is, when you compare with your database, it's highly scalable. The advantage of your Snowflake is highly scalable. It can store large amount of data. When you compare with your database, so always we compare your database with your data warehouse, because traditional systems still use databases for storing data. Like analytical, when you are working on analytical systems, you go for data warehouse system. That is why we are comparing with the database. So when you compare with the database, which is a transaction processing system, so your database, your data warehouse. So here I write SQL. I can write DDL, DML, create tables, and then work on accessing tables and using it, but it is not scalable. The problem here is it has a scalability. It cannot handle large volume of data. Whereas my data warehouse is highly scalable. So scalability is the biggest advantage of data warehouse system. So how it is scalable? From the architecture, we can understand that. Okay, how it is scalable. So we will see that. Okay, so in Snowflake, if you see the architecture, so this is the architecture of Snowflake. We have three layers. So we have three layers: cloud storage, cloud services, and compute. So we have three layers. So storage layer, warehouse layer, and services layer. Okay, so these are the three layers we have. So we are going to compare with the traditional systems, how this architecture is different. So here, if you see storage layer and compute layer are separated out. Okay, so in your Snowflake, there is a clear separation between storage layer and compute layer. Okay, so why it is separated? So it has a lot of advantage here. So it has a lot of advantages because of your separating it. So your user is running a query. The query is run on warehouse on computation layer. Okay, so queries are going to run on warehouse, and data is stored permanently in your storage layer. Okay, so your data is stored permanently in your storage layer. The query is ran on warehouse layer. So this is called as compute layer is a query processing layer. This is where query processing is done. And actual data, the permanently data is stored in the storage layer. So this data, why it is called cloud storage? Because it's using cloud. It's storing the permanently data in the cloud in the data lake. Okay, so in your architecture, Snowflake is using cloud data lake for storing the data permanently, and it's using cloud VMs, virtual machines, for creating compute, and on top of compute you have services. Okay, all this thing are built as a product. Okay, are built as a SaaS product, and it is managed by Snowflake. Okay, it's a proprietary of Snowflake, so we will not able to see a lot of things. Okay, so Snowflake is a proprietary software. You need to get a license and start using it. So even though they are going to use our cloud account, they are going to use our cloud account and access storage, access compute, but we will not able to see a lot of things which are proprietary to them. Okay, it's a product which is managed by them, and we create tables. We do it everything from web UI. So using web UI, we do the administration stuff. So if I go to the web UI, so from Snow site UI, we are going to create users. So I can go here, accounts. I can create account. So this account, I can see here, AWS account. It's a cloud account. Okay, so I can create accounts and map accounts here. Okay, so I can go for a different type of cloud account. Okay, it can be AWS, Google Cloud, or Azure. So you can select different type of editions. You have standard, enterprise, business critical. So you already have created a trial account. In the trial account, your already account is created and you have admin privilege. So you have admin privilege. So you have options to do admin stuff here. So in the Snow site, you have options to do admin stuff. You can see all the admin privileges here, like creating warehouse, running SQL. So you have all the options. So we have already a Snowflake account, which is on the cloud. Okay, so it is on the cloud, and that is tied up to your AWS account. So it's tied up to AWS account. So this AWS account has a data lake as a storage. So your architecture is going to use your storage account. Okay, so it's going to use a storage account and VM provided by cloud, and on top of that they have their proprietary software services. Okay, they have their software services. So what is this all this thing? We will see layer by layer. Okay, so first let us see traditional data warehouse architecture. So traditional data warehouse architecture. So in a traditional,
Bill, just to stop, want to ask question here. How do we link our AWS account, or how do you know that our account is linked with AWS?
okay. So in your trial account, so if you when you log in with the trial account, so when you sign up, so if you go to the sign up step, so when I'm accessing my Snowflake, creating my free trial account, it would have asked us to select the cloud. Okay, it would have asked us to select enterprise or what cloud you want. So it is linking up with your AWS or Azure. So your trial account is linked with your cloud. Okay, this cloud account is a demo account provided by Snowflake.
Yeah,
Okay,
I got your point.
okay. So this is a different account than my AWS account. If you see now, so I have one AWS account. So this AWS account, this account is different and this account is different. So this demo account is provided by Snowflake for me to practice. I can also add my account. So if I want, I can go and add my account. I can give my account details. So add my account. So if you add your account, they will start charging you for this account. So I don't want to charge initially. So for practicing, I'm going to use the demo account and then I'm going to practice it here. So I will not be charged for using this account. For using this, storing data in this account, I will not be charged. So if I add my Snowflake account, if I add my AWS account, I will be charged. Okay, so you can see the charges here. So if you are going to use enterprise, it's like $3 credit. So you are going to use your storage is $23 TB and warehouse is $3 here. Okay, so they are going to charge you two things here. One is for warehouse, one is for storage.
So
Storage,
for free trial, it has been charge free, right?
yeah, free tier is completely free.
Okay.
Okay, so you don't have to add your account initially. So if you want to add your account, here is the place where you can add your account. You can select the region, where is your AWS account, and then choose the enterprise version or standard version. Then you can add your account. Okay, give your account name, username, password. So your account will be added. So from AWS provided account, you can switch to your account, AWS account, and start using from that. Okay, so that is how you can switch to your account. But for now, initially don't do it. Start using free account provided by AWS. Okay, so you can practice here where you will not be charged. You are using everything free. So you'll be like you can use all these features provided by AWS. Okay. So when you are signing up for the Snowflake, you are going to choose here AWS or Azure. So I would recommend if you are from Azure background, like you can choose Azure here, or if you are from AWS background, choose AWS here. And if you are someone new, if you are accessing Snowflake and cloud first time, you can go for AWS because lot of features in Snowflake works good with AWS because they started with AWS. So
Yeah,
lot of
one question, can it be changed later? Suppose I select first time Microsoft Azure, then going to the account or admin, is there any provision to change it later, or once it is created, done?
so you can create multiple accounts, you can have multiple accounts, but you have to do the data will not be there. Okay, the data. So your data has to be moved. You have to create a replica and the data has to be moved. Okay, you can
Okay.
have multiple accounts, but data will not be there. So you have to move from current account to the new account by creating a replica.
Okay.
Okay. So far we are discussing about the architecture. So in your trial account, you can see a AWS or a Azure cloud account is already there. Okay, so it's already there in a particular region. So why region here? Because your cloud are region specific. In your cloud, there are multiple regions. So So your cloud is a data center, right? They are providing data center. The AWS data centers are across the globe in different places. So they have data center in different places. So when you are creating some resources, you will choose some data center. Like for example, I'm choosing Mumbai AP South 1 and creating my resources here. Okay. So if all my resources will be created in this data center. Okay. So when you are selecting Snowflake, you may select the particular regions here. So you will select the regions. So your all your resources will be on a particular region. So if you are going for a different region, there can be different regions from your region. There can be a small delay, but you can access different region also. It's not that if you are in India, you cannot access US or you cannot access UK. You can access always different region, but there will be a small delay. Okay. So here, so in a traditional, we will compare now with the traditional data warehouse architecture with the Snowflake architecture. So in the traditional data warehouse architecture can be two types. Okay, shared disk architecture, shared nothing architecture. Okay, so like 10 years back or 15 years back, there were no cloud-based data warehouse system. Companies were using shared disk architecture or shared nothing architecture. So what is this shared disk architecture? So in a shared disk architecture, they have a big data system where the data is shared across multiple nodes. Okay, so they have one centralized data system that is shared by multiple nodes. Okay, so here the disk is shared by multiple nodes. They take the data and do data processing. So they take the data and they do processing on the nodes here. So the shared disk architecture, it's not scalable. Okay, the problem with shared disk architecture, after a point, you cannot scale it. So let us go to the shared disk architecture. Okay, so in shared disk architecture, you are using same disk, same storage. You are having multiple nodes. Nodes are servers. Okay, so each node can read and write to the centralized storage system. So these are like the old systems like IBM DB2, Oracle systems, were built on this architecture. So it is used in banking. It's used used in insurance companies for transactional processing. So all this shared disk architecture were used in a banking and different insurance for transactional processing. Okay, so again, other architecture is shared nothing architecture. So shared nothing architecture where your disk is shared. So your disk is shared, it's not shared. Your disk is used between the node. So each machine has a disk. They have a CPU and RAM. So here, each machine has their own disk. Okay, so it's like a multiple machines are created and formed as a cluster here. Okay, you by using multiple machine, you form a cluster and data is there in all the machines here. Okay, the disk is there in all the machines and data is there in all the machines. So you have a replica of data in all the machines and you use the CPU and process it. So this is again another architecture. So it's used in Cassandra, Redshift. So Redshift still uses shared nothing architecture. So it's like by using small machines, you form a cluster and by using that you process the data. Okay, so this is again a traditional architecture. So it's again a traditional architecture. So Redshift, Cassandra, BigQuery, Teradata, all the softwares use the shared nothing architecture. In shared nothing architecture, the problems are you have to create partition. So you have to create partitions. So you when you create a table, you have to define the partition key. Then your data will be distributed and stored. Okay, so here you have to do manual tuning. You have to do fine tuning of your queries. You have to create a partition column. So you have to do manual work to improve performance. So with Redshift, with Cassandra, so with Redshift or Cassandra, you can store the data and you can, it's highly scalable. So the advantage here is when you compare with shared disk architecture, this is highly scalable. You can add more machines. So if I have 10 machines, I can scale it up to 20 machines, 30 machines based on my volume of data. But the problem is it has to be fine-tuned. So there should be IT team. They should be creating partition. They should write a query. So it uses a partition column. So when they are going to do, they have to do fine tuning of this thing. So it's highly, they should have IT team to manage this shared nothing architecture. Okay, so the advantage of the system is it's highly scalable and each nodes work independently. The CPU and RAM can process the data from the disk. So each node works independently. The problem is the data is not distributed properly. So when you work on joins, when you work on like a large data set, there can be performance issue if you don't partition correctly. So there can be data partition issues. So you need to have a strong IT team to manage this. But this system is already there, like a Redshift, Cassandra is already there, BigQuery. All the systems are used in enterprise and they solve large problems and it is used for analytics. It's used for analytical query. In OLAP system, this is used. So in Snowflake, is using a hybrid approach. Okay, Snowflake is using a hybrid approach. Snowflake, as we discussed, we have three layers. Storage layer. So storage layer uses shared disk architecture. Okay, storage layer uses shared disk and compute layer uses shared nothing architecture. Okay, so your Snowflake uses a hybrid approach, combining both. So in your Snowflake, cloud storage is a shared disk. This is a shared disk, and your warehouse is a shared nothing architecture. Okay, that means we are separating Snowflake. We have three layers, and it is a hybrid approach of your traditional system, where here storage is a shared architecture, the disk is shared across all the services. So it works on a shared disk architecture, and your compute is a shared nothing architecture. Okay, so that is a difference. So your storage is a centralized data store, and it is working on a shared disk architecture, and your compute layer, warehouse, is a shared nothing architecture. Okay, so what is the storage? Storage is your data lake. You are using your data lake for a permanent storage of data. Okay, so it can be S3. So if you're using AWS, you use S3. If you're using Azure, you use Blob, Azure Blob, so ADLS. If you're using GCP, use GCP data storage. Okay, so we have different kind of cloud providers. From the cloud providers, we are using the data lake for storing the data permanently. And how the data is stored? The data is stored in column level format. Okay, the data is stored in column level format, not in row level format. So your traditional RDBMS system stores the data in row level format. Okay, so traditional systems stores the data in row level format, but your Snowflake analytical system, so here with Redshift, BigQuery, or your online cloud data warehouse systems uses column level storage. Okay, so what they do, instead of storing in row level, they store the data in column level. So they also compress the data. Okay, they don't only store it, they also compress the data and store it. So they do a compression. So there are a lot of compression techniques. We zip the file, right? So compression is nothing but zipping the data and storing it. So when they store the data into the storage layer, so in the storage layer, they store it into data lake. They store it in a compressed form. Okay, and they store it in a column level form. So column level storage is a very important one to understand. Give me a few minutes.
You are not audible, sir.
Yeah. Give me a few minutes. I'm
Okay, okay,
just
okay,
searching
sure,
for the.
sure.
Okay, I cannot find the slides. It's fine. So, column level storage is a technique used for storing the data. So, let me go and search here. Column level storage. So, instead of storing the data in a row format, so this will be good. So, you can see column level storage. So, instead of storing in a row format, we are taking the data and storing in column format. So I can do compression, I can do parallel. So by using column level format, by using a column level storage, you get lot of advantages. You get lot of advantages. So you can compress the data in a column level form and do partitioning. So what is partitioning? So partitioning is splitting the data into multiple parts and then storing it. So I'll go to S3. So I'm going into AWS. I'll go to S3. S3 is the data lake. So I'll explain it, how you can create buckets later. So for now, I'm going into S3, your AWS cloud data lake. In that, I'm accessing a bucket. So I'm accessing bucket. The data are stored here. So data are stored in different format here. So data are stored. The table data can be stored here in a column level form. So your table data can be stored in column level format here. So let me go into one bucket. So data can be saved here in a CSV file, JSON file. So your data lake, you can store the data in different format. I can store image data, I can store video files. So your data lake, you can store any type of data. So in this, if I want to store my data, table data, I can store it in a column level form. I can store in a compressed form. So for example, if you see here, I'm creating multiple tables. I'm creating multiple tables. So here you can see chunk prediction, fraud detection, all this thing are table data. So I'm storing here in a compressed form as a Parquet. So Parquet is a compression technique which is used in the big data system. Okay, so I'm storing it in a binary form. So I'm compressing the data, storing in a column level format. Okay, so Snowflake uses this kind of strategy for storing the data. So they use this kind of strategy for storing the data internally into the storage system. So internally in their architecture, in the storage layer, they store the data in a column level form. They compress the data and store it in data lake. Okay, so we cannot see that. We cannot see it. It's proprietary of Snowflake. We cannot go to the bucket. We cannot see, like as I show here, I'm showing some another data, right? But I cannot see my data, which is proprietary to Snowflake. They are not going to show that data. So they will not show what format they have showed, what kind of technique they used. They are not going to expose it. But they are saying that we are using a column level storage and we are storing the data in a compressed form. So your data is permanently stored here in data lake. So the data is stored permanently here. So my data is in compressed form. It's stored in column level form. Okay, so data is stored in column level form. So as I stored in column level format, I get lot of advantage. Okay, I get lot of advantage. So I can select only few columns. I can, as I'm storing in column level format, I think that my table has 100 columns. My table has 100 columns. I want only 10 columns. So by selecting only 10 columns, in my query, if I select only few columns, and if I don't select all the columns, when it's going to take the data, it will select only few columns and ignore the other column. That is the advantage of using column level format. With a column level format, you are going to get lot of advantage. So it allows you to fetch the data in a, so we call it as pruning. So you have a better pruning with the column level format. So we'll discuss about column level format, how Snowflake does the data, all this thing we'll discuss about later. For now, you can remember that in storage layer, data is stored permanently within the data lake in a compressed form in a column level storage. Okay, that is what you can remember now. Later, we will discuss about how partition pruning works, how faster queries are fetched. We will understand about that later. So in storage layer, it uses S3, stores the data in column level form, column level storage, and it has other features. In the storage layer, it has other features. So they store in micro partitions. So what is micro partitioning? So in Snowflake, by default, it converts your data into smaller buckets. Okay, it converts your data into smaller buckets and stores in small buckets, in small partitions. So as I showed here, if I go to S3, so here I showed you some data, right? So I showed some data where if I can go to table, so I can see a Parquet file. So I can see the size here. So 291 MB. So this is one file, right? So if I'm storing a large data, so if I'm storing a large data, let us say it is 1 TB of data, Snowflake internally converts into smaller partitions, into small files and stores it internally. So that is what we call it as micro partitioning. Micro partitioning is about converting your big files into smaller files. Okay, so internally in the storage area, your data are converted and stored in the micro partitions. So the micro partitions, the size, there is a default size in Snowflake. So there is a size limit of, so you can see by default 50 to 500 MB. Okay, so your each file size, the compressed micro partition size is 50 to 500 MB, which is going to be 60 MB of raw data. Okay, so if you store 1 TB of data, your Snowflake internally will split that 1 TB of data into small files, multiple small files, and it is going to save. Okay, so internally, my Snowflake is going to store into micro partition. So in my data lake, your Snowflake will store in small partitions. So my one file will be splitted into multiple parts and stored in micro partition. So in each micro partition, the data is stored in column level form, and the column level statistics, the column level metadata, we call it as metadata, are stored in service layer. Okay, so in the permanently stored data are stored in partitions and micro partitions, and the statistics or metadata is stored in the service layer. So if you see here, let us come to the architecture. So in the storage layer, your data are stored in micro partition. That means you are like you are sending, you are storing 1 TB of data. Your 1 TB of data is converted into small files, and that is a column level stored format. So that small files is stored in the storage, and it is like the metadata is stored in the service layer. Okay, so you can see the metadata. So metadata is a statistics. It tells you in the micro partition what are my columns are, what is the min value, max value. So it provides you the statistics. So when you are doing queries, your queries are going to use the metadata and fetch the data. Okay, so that is how it is going to, your Snowflake is going to do faster SQL. So when compared with other traditional data warehouse or the current cloud-based data warehouse, Snowflake is faster in fetching the data. It's very faster in fetching the data because of micro partitioning, because of the metadata management, because of all the architecture design it is. Okay. Uh, so it's using column level format, it's using metadata, it's using the micro partitioning techniques to fetch the data fast. Okay, so that is how Snowflake is faster. So here you can see we are discussing about multiple techniques here. We are discussing about multiple techniques. So your data is stored in column level form. So your data is converted into micro partitions, and partitions, micro partitions, metadata is stored in the service layer. So we are discussing about a lot of things here. So we need to know all these concepts. So you need to know all this concept to understand the optimization, performance tuning of your Snowflake. Okay. So when you run a SQL, when you run a SQL, so I'm running a simple SQL. Snowflake internally does all this thing. So Snowflake internally does, when you run a SQL, Snowflake fetches the micro partition, it takes the metadata, scans the micro partition and pulls the data. So you need to understand how Snowflake internally works. Then only you will be able to visualize what is happening when you run a SQL. Okay. So far we are discussing about storage. In the storage layer, data are stored in micro partition. So and the data, Snowflake maintains multiple copies of data. Okay, so Snowflake maintains multiple copies of data. That means we are using data lake as a permanent storage layer here. Okay, so data lake are cheaper. So for 1 terabyte of data lake they charge like monthly $20. So your data lake are cheaper. So I can maintain multiple copies of data. So your Snowflake you can maintain versions. So that is what we call it as time travel. So in Snowflake, as they are using data lake for storing data permanently and it is cheaper, they can maintain multiple versions. They can maintain current version, they can maintain previous version, other like they can maintain. So if you are using enterprise version, they maintain 90 days of your data. Okay, they maintain 90 days of data. If you're using standard version, so the Snowflake has different versions, standard, enterprise, and so if you go to accounts, so you can see standard, enterprise, and business critical. So you can see three type of enterprise editions. So you can use standard. So in standard version, they don't maintain history. They don't maintain versions. In the enterprise version, they maintain data for 90 days. So that means your data, historical data is maintained. So I do updates, I do deletes. So all my data copies are maintained within the Snowflake. Okay, so like I see few questions. You can ask your question in the chat. If it is relevant to the current discussion, I'll explain it immediately. Or we'll discuss about in the last 15 minutes. We will discuss about all your question and answer. Okay, so if it is relevant to the current one, you can unmute and ask your question. Okay, so
Can you, is there timetable and fail-safe? Is the course is completed here, or will it be discussed later?
no, we are seeing only the architecture. We are not going to. So later we will discuss about time travel,
Yeah,
cloning,
I
fail-safe, all
want
this.
that discussion in details. Yeah.
Yeah, so at present we are discussing what is happening in the storage layer. Storage layer. In storage layer, what is responsible for? Okay, that is what we are discussing. So time travel,
So,
your
so are we
storage
going to
data.
are we going to start doing the lab very soon, like practical hands-on, to see
Yeah,
how
we are
these
going to do it,
things?
right? We are going to do it.
Okay. I have another question. Does the storage layer that you are or that you have supporting your data warehouse, does it affect the performance of your data warehouse queries?
Yeah, that is why we are discussing, right? So your storage layer. So if you see with the traditional system, so what is different here? So with the traditional system, we have a multi-layer architecture and we are storing here in micro partition. So I am storing in micro partitioning and my metadata are there in service layer. So in metadata, what is metadata here? It is maintaining my data's min and max value. So your statistics informations are there in the metadata layer. So when I'm going to run a query, if I apply some filter condition, so my filter condition will be applied to the service layer in the metadata, and your data will be fetched faster. So from my micro partition, from my storage layer, as we have stored the data in micro partitions, and we have metadata for that. So when I'm applying filter condition, so in my queries in my SQL, my queries will be faster because of all these approaches, because of micro partitioning, because of the metadata management. My queries will be fetched faster. So we are avoiding full scan. So in a big data system, how you can improve performance, how you can do a faster queries by avoiding full scan. You should not do full scan. When I have large amount of data, if I have 1 terabyte of data, if I'm going to scan the entire data from your storage, your performance will be poor. Okay, so instead of doing full scan, you are doing partial scan by using the micro partition. That is what we are understanding by discussing about architecture.
Okay.
Okay, I have a
Sorry.
last question. Is it our responsibility as data engineers to define and to define the partitions? Are we
If
the
it
ones
is
that
a
will define?
if it is a large table, let us say you are using a data is more than 100 million, then you need to define the clustering key. So in that, while creating table, we have to define the clustering key for larger table. So that is
Okay.
responsibility of us.
Is there anything to define whether larger table we are using or small table? Any size definition is there?
So when we will define the clustering key. So when creating table, we will define the clustering key. Only for the larger table, we will define it. For small table, we don't have to do it because Snowflake has by default micro partitioning. So it creates micro partitioning automatically. When compared with other data warehouse systems, if you take Redshift, you have to create partition for all the tables. Because it doesn't have micro partitioning concept at all. So you have to define when creating table, you have to create the partitions. With Snowflake, you don't have to define the partitions. Only for larger table, the data which is more than 100 millions of bigger data set, you will create, while creating table, you define the partition columns. Otherwise, you will not define.
Yeah, got it. Thanks.
Well, one question, since
Yeah.
Snowflake is a data warehouse, in this cloud storage, is it storing the raw data or is it storing the transformed data after the ETL process?
It's going to be both. You store raw data also, you store transformed data also. So Snowflake can have different type of data. So I can have raw data also, I can have transformed data, I can have gold data also. Like we have different kind of data. So you can store all this different type of data in Snowflake.
Understood. Okay.
If you're
So
using S3 bucket versus Azure Blob storage, does it affect what kind of data and storage partitions and all that, or it doesn't matter?
It doesn't matter. So if you're using different cloud also, it doesn't matter because they are using the same technique on other clouds. So it doesn't matter on that. And we are not doing anything on this, right? So it's internally done by Snowflake. We are not controlling all this thing. So we are working on tables, we define clustering key. So we are understanding all this thing to know what is happening in the beginning. When you do all this thing, what happens beginning, that is what you're understanding. But all this thing are proprietary of Snowflake. They are doing it internally. So they are using the data lake, they are building the storage layer, they are building the warehouse layer, they are building all this.
Okay, nice.
Okay.
when you said about the micro partitioning, right? For example, with Snowflake, it gives you faster access when we run the queries. So in the sense, in the cloud storage, if it is a 1 terabyte and there are 10 partitions, let's assume there are 10 partitions, and the metadata will be having all the informations of the 10 partitions.
Yeah, it'll have. So your metadata will look like something like this. Let me show it. So you can see it will look like this, where you have the column details and column minimum value, maximum value, some count, it will have all this informations. So it knows. So if I'm using some data, it will go to the, if I'm writing a SQL, my SQL will first fetch the metadata, use the metadata and scan the micro partitions. So it's not going to do full scan. So always apply the metadata and do a partial scan. So the first level itself, you are not going to do full scan. You are going to take only one. You have 1 terabyte of data. So you are not going to scan all the data. You are going to take only few data by using metadata service here. You are going to take only few partitions, micro partitions, and use it for your queries.
So in general, like as you say for filtering, right? So
Yeah.
the metadata will understand like what I am filtering and where the data is present in which partition, and it will go to that particular partition and
Correct,
will
correct.
fetch the data, right?
Yeah, yeah. So that filter, the filter condition, you will use it as a clustering key. While creating table for a larger table, you will create as a clustering key. So if it is a small table, Snowflake will take care of doing it automatically. If it is a large table, we create the clustering key and we use that column in the where condition. So it will go only to that partition and take that partition and ignore all the other partitions.
Okay, so in that case, if a query is fired by a user, the query first hits this layer, right? Cloud service layer, where the
Yeah,
metadata will
yeah,
tell or scan which partition the query should go and scan the records.
correct.
Okay, okay.
So in this way, the query will be the first.
Correct. So that is the mechanism behind the architecture. You can see how Snowflake is running faster when compared to other data warehouse system or cloud warehouse system. The architecture is key. The architecture is designed such a way that their queries are going to be faster because they have the metadata layer and the micro partitioning. They are not going to do by default. They are doing micro partitioning for all the data. So when you take Redshift as example, right? In Redshift, we have to define the partitions. When you're creating table, we define the partitions. So you tune the partitions. So if you want to improve the performance, you tune the partitions. Whereas in Snowflake, micro partition is defined by default. So you are going to have metadata management by default defined. So you don't have to do it. You don't have to do the tuning. It is automatically defined. So for only bigger tables, we create the clustering key. Otherwise, you don't have to define.
Just last question. Well, so
Yeah.
micro partitions can only be created for structured data or also for semi-structured data?
Structured it.
Structured data only.
Yeah. Semi-structured data, we will flatten it to structured data. Okay, so we will discuss about it. So your semi-structured data is stored in the storage layer. Okay, semi-structured data is stored in the storage layer. Metadatas for the all the structured data is stored in the service layer. Semi-structured data is there in the storage layer. So we will do flattening and convert into structured data.
Okay, okay.
Okay, so far we have discussed about storage layer. So compute layer, virtual warehouse. So in Snowflake, whenever I write a SQL, so I'm going to Snowflake, I'm creating a worksheet. So I can access any table, I can create a database. So I can create a database. So I have multiple options to do. So I can use SQL, create database. Create schema. So I can select everything and run together. So my database is created. My schema is created. I can refresh here and check it. So my database is created. My schema is created. Okay, so here I can create a table. So I'm creating a table. So here I can see the data type here, integer, date, numeric. So Snowflake has their own data type. So like your SQL, MySQL server, Snowflake has their own data type. So when you are doing migration, you have to convert into Snowflake data types. So you have the string, varchar, all this thing supported. So here I'm creating integer type. And so let me create this table.
Are all these tables, databases also getting stored in cloud storage or no?
So all this thing are getting stored in cloud storage.
Okay, okay. But we just understood that whatever is stored in cloud storage, we cannot access that. But here, when we are creating a table, database, or schema on the left-hand side pane, we are able to access those.
No, like I'm saying that even though the data is stored, we are creating a table, I'm inserting some data. Let me insert some data.
Mhm.
So we have created a table, we have inserted this data. So this data is permanently stored. If you see, the data is stored in the data lake, which is used by Snowflake. So if the actual data is stored in data lake, but we cannot see that, it's stored in a compressed form, column level stored in the data lake. You can access it only from web UI or from Snowflake interfaces. Snowflake provides different type of interfaces. They have command line utilities, they have web interfaces. So they have different interfaces. From that only you can access the data. Okay. So here you have, like, you have logged in with account. You are using Snowflake web UI and you have authentication. So you have done authentication. So you can access the table. So only from the authenticated layer, you can access the data. That is what I was telling. You cannot go directly to your account, AWS account, data lake, and access the data. That is what I said. You cannot access the data from data lake directly. But from the table, using SQL, I can access the data. So is it clear?
Okay, yeah.
I see that you're connected as account admin.
Yeah.
Okay,
So by
so
default, this is a super admin user. Okay, so I'll explain what other users are there. Roles we will discuss about this later.
okay.
For now, so I'm logged in. When in your trial account also, when you create an SQL file, by default you will get admin privilege. So the account admin is a super user where he will have all the privilege. He can create users, he can delete database. So you will have all the privileges. So there are other roles. There are multiple roles. So we will discuss about all these roles later. So for now, we will use account admin and we will create tables. We will run all this thing as a super admin user. So here I created a database. I created a schema and I created a table and inserted data. So when I inserted the data, this data is stored permanently. So this data I'm inserting few records. Even though I'm inserting few records, let us say I'm inserting huge data here. So all these data are converted to micro partition and stored in your storage layer. Stored in storage layer, and it is using warehouse. You can see it's using warehouse. So without warehouse, I cannot run queries. Okay, if I need to run queries, I need warehouse. Okay, warehouse is the compute layer. So warehouse is the compute layer. So the data is stored. The data is stored in storage. Warehouse is a compute layer, and service layer has the metadata and your web UI. So whatever we are doing it in web UI, you are interacting with your service layer. So web UI is on top of your service layer, where you are doing access control and you are accessing service layer through the service layer only. We are creating tables, we are inserting data. So we are using service layer only. We are performing all our integrations here. Okay. So in your architecture, let us go back to the architecture. So your compute layer is responsible for query processing. So it's responsible for query processing. So if I stop my warehouse, I can go to compute. I can stop the warehouse. I can go here, suspend my warehouse. Okay, so if I suspend, if now I cannot do query processing. my query is processing because for running a query, you need warehouse. Okay, so warehouse layer is responsible for running your queries, and it is a parallel processing layer here. So it's going to run it your data in a parallel way. So your compute layer, you can scale it up. It's a highly scalable one. You can scale up or scale down easily. Okay, so you can see here in warehouse, I can create warehouse. I can go for small, X small, medium, large, X large, different kind of warehouse. And I can choose generation 1, generation 2, optimized. So the generation 2 is latest one, where they are providing you some optimized ones. But in generation 2 also you have small, medium, large, like a t-shirt size. Okay, so let us go to generation 1 itself. So in generation 1 you can see, so X small, 1 credit per hour. So if I use for 1 hour X small, I'll be charged 1 credit. Okay, so when I created the account, so you can see when I created account, so you can see when you're choosing enterprise, you will be charged 3 credit. Okay, 3 credits. And in the warehouse, if I run a query, so if I'm going to run a query for 1 hour, I'll be charged for 1 credit. So 1 credit is used like this credits, like it will be converted to dollars. I'll tell you about dollars, how it is converted to dollars. For now, 1 credit. So in our trial version, you have 400 credits. So if you are going to run warehouse for 1 hour, I'll be charged 1 credit. So if I'm going to go for small, I have 2 nodes. Going for medium, it's 4 node. So what is this small, large, all this thing? It's a virtual machines. So all this thing are virtual machines. So you are small, 1 node, it's 8-core CPU. It's 8-core CPU and it has 16 GB of RAM, 200 GB of local disk. Smallest 2 nodes, 16 CPU, 32 GB, 400 GB of local disk. So it's nothing but a virtual machine. So your compute layer.
Just one question, what does it local disk mean? I mean,
So with your warehouse, you have a disk that is called local disk.
sorry, your voice is not clear.
So is it clear now, or my voice?
Yeah, it's better. It's better.
So in your virtual warehouse,
Mhm.
it's a VM. It's a VM. So this VM has a disk also. Okay, this storage is a data lake which is permanently stored, and this virtual machines has a disk CPU. It's nothing but a machine. So it's like a VM, right? So in the VM, what you have in a VM, normally virtual machines. So let us say in AWS, you are taking a virtual machine. So I'll go to AWS. So if I'm going to EC2, so EC2 is a virtual machine. You are in AWS, I can create a virtual machine. So if I create a virtual machine, I can have with my virtual machine. So I can choose what type of machine I want. For example, if I'm going for any mission, so if I create a mission, I get some CPU, I get some memory, I get some disk. Okay, so I get by default in your cloud. So when you create a warehouse, you get, if I'm creating a small, I get 8 CPU, 16 RAM, and 200 DB local disk. Okay, so like if you are going for medium, you get 32 CPU, 64 GB of RAM, and 800 GB of. So your warehouse is nothing but virtual machines. Your warehouse is a virtual machine. So when you are working on query processing, your queries are ran on the virtual machines, and computation is done on this layer. Your query processing is done on this thing. So I can scale it up, I can scale it down on my need. So I'm running so for example, let us say I'm running in morning, I'm doing some small processing. I'm creating tables, I'm creating some schemas. So I'm working for creating some operations for my development. For dev activity I'm doing. For that I can use a smaller warehouse. So in my warehouse, I'll go to my Snowflake warehouse. I have different kind of warehouse. You can see I'm having small, I'm having medium, I'm having large. So I created different warehouse. So when it is suspended state, I will not be charged. So when it is in suspended state, I will not be billed. Only it is when it's running stage, I'll be charged. So I can start small. I can run my small. So I can say that resume. Okay, so I can start my small. So here, when I'm creating warehouse, when I'm creating warehouse, I can define some configuration. I can define auto resume. I can define auto assessment. Okay, so that means when you run a query, automatically this warehouse will start, or it will get automatically suspended when you are inactive, when your queries are not used. That means there is no queries fired. So you are inactive for 5 minutes. This warehouse will get suspended automatically. So this configuration you can define it. So your warehouse, I have different type of warehouse, small, large, medium. So I ran some simple work. I'm creating some tables. I'm creating some database. So I can use small. So next, I have another team. I am having a data science team. They are going to do heavy operations. Okay, they can stop this warehouse, or they can parallelly start this warehouse. They can start this one, data science warehouse, and start using this data science warehouse. Okay, so they can use it for 30 minutes. After using it, they can stop it, or it will automatically suspend. So if there is no activity, it will suspend automatically. So for a day, your medium warehouse, the data science warehouse, is used only for 30 minutes. Okay, so I'll be billed based on the warehouse. Okay, based on the usage, I'll be billed. So that is what your Snowflake is providing you. So as we have separated the storage separately and compute separately, so I have option to my billing, I can control it. So if I want to run faster, I can go for a bigger warehouse. I can go for a bigger systems. If I don't want, I can use small instance. I am okay with that. My query performance are fine. I'm running smaller operations. I can use small warehouse. So my cloud storage layer is separated from my compute layer. Whereas if you see Redshift, where if you see other systems, right, their compute and then the storage are integrated together. So when you scale it up, you have to pay for both. So when you scale it up, if I'm going to add more machines, if I'm going to increase my power of my cluster, when I'm going to add more machines, I have to pay for both. When I'm scaling up, I have to pay for compute also, storage also. But here you have option. I can my cloud storage layer is cheaper because it's using data lake is cheaper, and my compute layer, I can scale it up on demand. So if I'm running some large process, I can use large warehouse. I can go for medium, large. If I'm not using it, I can suspend it. So this option you have control over it. So for example, when I'm running a query, so I'll go to my worksheet. So I'll open the worksheet. So here I'm running a simple one. So I can use small. Let us say I'm going to run a bigger one. So I will go to the Snowflake sample data. I'll go to TPCH 1000. So I'll open this orders. So I'm going to get the count. So I'm going to get the count. So I'm getting the count of orders here. So when I run this query, so this data set is a very huge data set. Let me go into, I will open in a new tab. So the query ran and the output is here. So you can see the output. This is a very huge data set. Okay, this is a very huge data set. The count, when I ran count, it fetched from the metadata layer. That is why it was faster. So the count, as it is there in the metadata service layer, the count came in 200 microseconds. Okay, so because this is there in the service layer, it brought it fastly. So if I'm doing a select star limit of 100, I'll run this query. So it is 2.7 seconds. I will apply a filter. So I'm applying a filter. So you can see the performance is slow, okay, because I'm running in a smaller warehouse. It's taking a lot of time to run this. So I can cancel this query. I'm canceling it. I'll go for a bigger warehouse. I can go for my data science. I'm switching my warehouse.
One question.
Yeah.
In the organization level, companies also monitor the credits of the employees that we are
Yeah,
utilizing?
yeah. They monitor it.
Yeah, because that will impact the
Yeah, that will impact. You will not have access. So
Mhm.
for like a warehouse, you will not have access to all the warehouse.
Right.
Based on your role, your permissions, you will have access only to limited warehouses, and that will be monitored also.
And as a developer, if we know we have to work on very large queries, then we will have to request Snowflake.
Yeah, you have to get a
Mhm.
business approval, and you have to
Okay.
request for a warehouse. Then they will admin. There is a Snowflake admin. They will see the approval, and then they give you access.
Understood. And just one more question, well, from scalability perspective. So I generally understand that scalability or elasticity is of two types, horizontal scalability and vertical. So in horizontal, we add more virtual machines, and in vertical scalability, we increase the size of a virtual machine. Now, in this Snowflake case, since we have warehouses of different sizes, does Snowflake only follow vertical scaling and not horizontal scaling?
It does both.
It
So we
does
have
both.
multi-cluster. So at present we are creating like the cluster, the warehouse
Mhm.
we created, right?
Right.
We created only vertical ones. So you have
Okay.
option here. You can select multi-cluster warehouse. Okay,
Understood.
you can add multiple clusters.
Understood. So in that case, the workload will be distributed amongst
Distributed. The queries
nodes.
will be distributed. So if
Understood.
you have multiple queries coming to your warehouse, the queries will be distributed and processed on multiple warehouse.
Understood. Understood. And one more question from partitioning, or let's say micro partition perspective, was, let's say I have a data which is of 20 countries, for example. Every country has 1 million records. Now, when I save this data, will the partition be created at a country level or any other dimension level?
So if the data size is less, right? So what Snowflake will do, it's going to take all your important columns, create a min and maximum values for all the columns, not only for country. For all the columns, it's going to create the min and max value and maintain it in the service view. So when you do filter, it's going to search based on your filter condition from the metadata and scan only the data. So by default, Snowflake is doing for.
Understood. So explicitly as a developer, we don't have to give that
Yeah, you
condition.
don't have to do it. Yeah, you don't have to do
Understood.
it. By default, Snowflake is doing it.
Okay. Okay. Yeah. Okay.
Okay. So if you see here, I'm running a bigger query and this my data is huge. So I cannot use a smaller warehouse. I'm going for a data science warehouse, medium warehouse, and running it here. So because I have access, I am having admin privilege. I can see this warehouse. So in your organization, you will be given based on your role, based on the use cases, you will get a business approval and get access to the warehouse. So here, if I run it on a small warehouse, the performance will be slow of the query. If I run a, you choose a warehouse, the size of the machine is bigger. The size of the machine is bigger. So this machine, I'm using medium. So the medium machine is 4 node. It has 32 cores and 64 GB of RAM. It's a bigger machine. So the processing capability, the parallel processing capability of the machine is bigger than the small machine. So you are going to have a faster performance. So based on your requirement, you can go for different values. So you can improve the performance. And you can, if you don't want to have a higher performance, then you can go for a smaller machine So you can reduce the cloud cost. So you have the option here. So by creating warehouse, you have the option of controlling your building. Okay, you have the option of controlling your building. So I'll go and stop this warehouse.
So there could be a possibility that I ran the query for the first time, let's say on a small warehouse, and it charged me something. Now after 15 minutes, I wanted to run the same query again without changing anything. So then again, I will be getting the same charges, or will there be some kind of caching that can be done?
Yeah, we will discuss about caching. I'll come to all this
Okay,
concept.
okay, okay.
Okay, so we will discuss about caching everything. So yeah, go ahead.
Question, please. When you created that table, I did not see you specify data types or anything. Does it?
So this is a sample data. So in previous session, I showed this. So in Snowflake, you have sample data. Okay, so you can see here.
Yeah, I
Go
know.
to
I'm saying,
database.
I thought you created your own table.
Yeah, I created my own table, which is data is very less, right? So here we have small data. So with this, I cannot show
Yes.
the performance, right? So that is why I took a larger data set, and then I was showing the query performance here. So this query, I cannot run it on small warehouse. I need to go for a bigger warehouse.
No, I understand. When
Yeah.
you created a demo
Yeah.
demo schema.sales, is that our table? You didn't
Yeah,
create
that's our
a
table. This is our table.
So when you
So this-
created this table, did you specify? Oh, okay, I see the data types now. Okay, thank you.
So this is our data type. So this is
Yeah.
a simple table which I created. I inserted values which are small records. Okay, so for showing the warehouse performance, I went for this query. Sample data set. So this has a lot of data. We will use this for performance, for seeing some scenarios. We'll use this data sets. Okay, so we will come back to the warehouse. So you can see here the advantage of separating storage and warehouse allows us to scale based on our need. Okay, so we can scale up or scale down based on our need. So I can go for a simple warehouse. So we have independent warehouses. We have independent warehouse, and you can suspend it, resume it based on your need, and you can do concurrent scaling also. And in the warehouse, you have cache mechanism. So what is cache mechanism? So your warehouse layer is a virtual machine. So it's a virtual machine. So inbuilt in the virtual machine, you can cache the data also. We call it as local cache. So if I run this query multiple times, so if I run the query again, so I can see the query here. I can see the query executed. The query ID here, I can go to the profile. So if I click on the link, it takes me to the query profile. So you can see here, how did the data came in? So initially when I ran, the data like it took, let me take another data. So I'll take another record. So let me go for another record. I'll use this key. I'll run the same query. So it takes like around 7 seconds. So it took 6.7 seconds. And if you see the 6.7 second, and I can click on this query ID and go to query profile. So you can see here, it shows the statistics. The query profile stores the statistics. We will see about all this thing later. So for now, in this query profile, I can see the data is getting scanned from storage. So this data, this query went to the storage layer, fetch the data from storage layer. So when I ran this query first time, it's fetching the data from storage layer. It's scanning the micro partition and getting the data from the storage layer. So if I run the query again, it's not going to storage, it's getting it from cache. So that is why it's 48 microseconds. So in your virtual warehouse layer, you have a caching mechanism, which if you run repetitive query, your data is going to come into from your warehouse layer. It's not going to go into storage layer. It's going to come from the warehouse layer. The first time the data came from storage layer. The second time it came from warehouse itself. Because the query I ran the same query again. So by default, in your warehouse layer, the queries are getting cached. So repetitive queries are getting cached. So you have a cache mechanism by default implemented in your warehouse layer. So if I run the same query again and again, it's not going to go into storage layer and fetch your data. It's going to come in from cache. Okay, so we will see discuss about cache detailing. So for now, in your warehouse layer, it's responsible for caching mechanism. It's responsible for scaling up. I can scale my compute layer. It's responsible for query processing, and I can control my billing. I can control my billing by controlling the compute layer. Okay, this is the one which is heavily cost. So this is the costly layer. I can control this by creating a small, bigger machines. I can control my billing by changing the compute layer. Storage layer are cheaper. Your storage layer are cheaper because here it's stored in your data lake, and data lake are cheaper. Okay, so you can see your data lakes are built on terabytes, TB per month. It's typically like $23 to $40 per month for a standard storage. Okay, so in storage layer are responsible for storing data permanently. Your query processing is done on the compute layer. Okay, so as we discussed, when user runs a query, he uses a warehouse. He runs on the warehouse. He uses CPU, RAM for query processing. The data is fetched from your storage. Data is stored in micropartition. So the data is fetched from the storage layer. So if a data is query is ran multiple times, it's not going to storage. It's going to get it from local storage by the caching mechanism. Okay, by the caching mechanism, data is going to come from your warehouse layer. And you can control the warehouse by changing the warehouse type. By changing the warehouse type, you can control the billing. Okay. So in your organization, you have different type of workloads. You have small ETLs, you have medium workloads, you have concurrent workloads, I have heavier workloads. So based on my workload, so different type of scenarios, you have different type of scenarios. I can choose different warehouse. So I can get business approval, create different warehouse. So different teams, they can use different warehouse and run concurrently multiple activity. Okay. So heavier workloads, let us say heavier workloads, I can create a 8-node cluster, a large machine, and run it on heavier workloads. So in heavier workloads, so when I'm running multiple query, so for example, here let us say I'm running a heavier workloads, or I can go for scenario 3. So scenario 3, I am using, there are multiple BA users, business users. They are running queries from different region. So the queries are getting queued. So I have one big warehouse. So I have one large warehouse, and my users, BA users, are running queries, multiple queries from different regions. And this warehouse is getting queued, and queries are running getting into queue here. So when concurrent queries are executed, when warehouse is busy, it's not able to execute. The queries get into queue mechanism. So to solve this, you can create a multi-cluster warehouse. Okay, you can create a multi-cluster warehouse. So multi-cluster warehouses, I can create multiple machines and make it as a one cluster. Okay, so you can, so here, when multiple queries are fired, each queries will run it on multiple warehouse. So this is again option, you have it. So when I create a cluster, you have option to choose multi-cluster warehouse. Okay, instead of using one cluster, you are using multiple cluster. So concurrent issues, when concurrently multiple queries are fired, and if it is getting into queue, we can avoid that by creating multi-cluster warehouse. Okay, this is again advanced one. We don't have to discuss now. We will discuss about this later. Okay, so in Snowflake, you have option to create warehouse. You can create a small warehouse. You can create a large warehouse. You can create a like a multi-cluster warehouse. So you have an option to create different sizes of warehouses. You can create one machine, one powerful machine, or you can create a medium warehouse with multiple medium warehouses. So you can create a multi-cluster medium warehouses. That option you have. Okay. So this Snowflake architecture is designed such a way that you can easily scale it up, your warehouses separately, and your storage is stored in a data lake, and that is scalable. So your storage is scalable, your warehouse is scalable. So all your entire Snowflake is highly scalable. So it can be used for large volume of data processing. It can be easily used, and it is faster. It is faster when comparable with all the data warehouse system. Snowflake is faster because of its like architecture. It's like because of its metadata layer, because of its micro partitioning. It's faster. It has a faster SQL because we are not doing full scan. We are avoiding full scan by using metadata layer. Okay, so we have discussed so far on two layers, on compute layer and storage layer. Let us go into cloud services layer. We will go into service layer.
The compute layer is basically a virtual machine, right?
Yeah, virtual machine.
And the virtual machine will have an OS also. So the operating system of this virtual machine will always be a Windows OS, or it
No, we will
depends.
not know that. It's proprietary of Snowflake. We know that it's a
Understood.
virtual machine. We don't know what operating system they use. So this architecture, we know the
Mhm.
high level architecture because they share this high level architecture. But we don't know what kind of warehouse it is. Is it a Windows machine or Mac machine? We don't know all this thing internally what they are using it.
Understood.
But we know like they use CPU, RAM. It has this call this thing. We know the resources type, but we don't know what kind of internal architecture we don't know.
Understood. Okay.
Okay, so far we discussed about two layers. The third one, service layer. In the service layer, where authentication, authorization, metadata management, governance, so all your it's a brain of the system. So this is your service layer is the brain of your entire Snowflake, where it controls a lot of things here. Okay, so when I log in from web UI, I log in with the username and password. So I do authentication. I define users. I give them roles. I give them permission. So I can create users. I can create roles and give access to the users. So I have different kind of database. I have different type of tables. So I can give read permission, I can give write permission, delete permission to the users, different type of users. So in my organization, there are 100 plus users. Okay, so I'm going to create users for them. I'm going to invite them. So I'm going to give an email and invite users to the Snowflake and give access to the tables. So I'm going to give read-only permission. So for a lot of users, I'm giving read-only permission. For few users, I'm giving write permission. For few users, I'm hiding permissions. So I'm not giving. So I'm giving table access, but I'm not showing all the columns. I'm hiding columns. So I do lot of access management. Okay, so I do access management. So in the Snow site, we are doing all this thing. This is part of your service layer. Okay, so whatever we are doing it on Snow site, we are doing it on the service layer. So your service layer is responsible for authentication, security, access management. It's responsible for governance, metadata management, asset property, and it's data sharing. So for a lot of things, your service layer is responsible, which is the brain of the system. So you write SQL to access the data. I write SQL. So we have different kind of interfaces. We have different kind of interfaces. So you can use web UI, you can use CLI. So initially we discussed, we can in Snowflake, you can access using different systems. You can use web UI, you can use CLI, you can use JDBC, you can access through APIs. So Snowflake, you can access through different mechanisms. So all this thing are service layer. So you are using service layer to access Snowflake. So using service layer only, you can enter to Snowflake, access the data. You will have privileges. So based on your privileges, you can access the data. Without service layer, you cannot access the data. Okay, so service layer is the brain of the system. So you enter the system using authentication or through SSO or different type of security mechanism, and you access the data. Okay, so user logs into system through service layer and they run a query. The query is run on warehouse. The data is stored in the your storage layer. So we have different layers. So we have covered all the three layers. So we have three layers. So we have covered all the three layers. So your service layer it's a core layer where it's responsible for the integration, interfaces, communication between all the layers is done through your service layer. Okay, so in service layer is responsible for I'm controlling my warehouse. I'm controlling my warehouse. So your service layer allows this. So as I'm using web UI is part of your service layer. I'm changing my warehouse. So I'm configuring my infrastructure. I'm adding an account. So I'm changing my cloud account. So your service layer is responsible for configuration, for defining your warehouse, for changing your warehouse, creating tables, creating database. So metadata like your DDL, DML operations. So your service layer is responsible for different kind of activity, for configurations, for infrastructure management, access control, governance, security. Your service layer is responsible. And service layer holds metadata. So we cannot see the service layer also because it's a proprietary of Snowflake. So we get access to the Snowflake like web UI and we start using web UI. So we work on the service layer. Okay, we can configure warehouse, we can configure we can configure the different kind of infrastructure here in the service layer. Okay, so this is about the architecture of Snowflake. So any question on the architecture?
Yeah, I have a general question.
Yeah.
Right. I mean, you have a storage layer, right? But the storage layer is for the Snowflake. But if I have something on my own S3, and if I want a query on that, can I use that my S3 as a storage?
So you will add it as a stage. So you will create a stage and you will add it as a stage and you can take the data from S3.
Okay, but when I'm adding as a stage, does it goes to our Snowflake storage? Or
No, it will
still...
not go through. It will not go
Okay.
through Snowflake storage.
Okay. And will that cost us more if the file is big or something, or?
So if your S3 you are having a data in S3, the data
Right.
is huge.
Mm-hmm.
If you bring the data, if you create a table and load the data into Snowflake, you will be charged. Okay, so if you are keeping it in S3, you will not be charged.
Okay.
And you are creating a stage and you are using it, you will not be charged.
But how it does the like Microsoft services or what those things, right? How is breaking down on my S3 is not, you don't have any capability, right?
So like if you want to do, take your data, bring it to, so by keeping the data in S3, you have the data in raw format. Okay, so if
Right.
you want to run a query, you have to bring the data into Snowflake. Then only you can do a query. Okay, you are having the data externally to the system, so you cannot do query on the data. So if you have to bring the data into Snowflake, then only you can perform query. So you will be charged for bringing the data into Snowflake and running the query on the Snowflake. So if you are going to run query, you are going to use warehouse. So you'll be charged for warehouse. So if you're for the SQL queries. So if you just have the data in S3, you will not be charged.
But well, if the data is in S3 and we are not getting charged and we are bringing that data into Snowflake, and Snowflake inherently is also using S3 as a storage, then what is the difference? Why it is not charged before and why it is charged now?
No, the charge is for the moving the data, right? Not for the.
So let us discuss so we will say two accounts. Let us say two accounts. So we have account 1, account 2. So the account 1, so my Snowflake is there in account 1. So I have Snowflake here. And may have Snowflake is installed in this account.
Mhm.
And I have S3 here in this account. And this S3 is the storage layer of your Snowflake. Okay, so here I'll be paying. So my table, whatever I create, so whatever table I create, the table will get created, this data will be stored here permanently. So I have a warehouse. So let us say warehouse. And this account, I have S3. So I have data here. So let us say I have 1 TB of data.
Mhm.
1 TB of data. So I need to take this data, run a SQL, analyze this data. So I want to take this data, analyze this data. So I have to, I can create a stage. So I'm going to create a stage. So I can create a stage. So stage, what it do? It is going to mount this bucket to this account. So I can access this data. I can access this data. So if I have to query, if I have to run SQL, I have to take this data, bring it into Snowflake, create as a table. Okay, so load it into Snowflake, then run the query here. Okay, so you need to create either as a temp table or you have to create it as a table and load the data. So you have two options. You can create as a temp table and then you can use that data here. So when you do that, you will be charged here in the warehouse. So you are going to pay for. So if the data is here, so if the data is here in this account, I'll be charged for S3 bucket. Okay.
Yep.
For this account, the account 1, if I run SQL, I'll be charged SQL for the logic. So here I'll be charged only for the SQL here. And if I create the table and load the data, I'll be charged. So otherwise, I'll not be charged here. This account 2, I'll be charged for holding this data in S3 bucket. Okay, so
when you
this
say
is how
the
the charges are.
when you say the create stage, right? So when you say
Yeah.
the create stage and we can access the data, in that case, will that all the metadata information is going to be stored in cloud service?
So here, when I create stage, I'm just linking this bucket.
Yeah, just linked. Yeah,
Link. This is a
bucket.
link. For
Yeah.
the link, I'll not be. This link, I'll not be charged much because
No,
I'm
no,
not bringing the data.
No, I'm not talking about a charge, but right. I mean, when you link that, will that
Yeah.
store that information like total record count and all that information in your cloud service or Snowflake cloud service, or it doesn't have anything? Just
So you are creating a metadata here. That means
right.
you are having some AWS configuration that will not occupy much of space here. So So it's very cheaper thing. You are going to store only the AWS configuration here.
Right, but still it reads those information, right? Total record count and all that columns. If I say that, okay, give me a count
No,
of
it's not going to do, right? Like let me create a stage, I'll tell you. So we will do it.
yeah, sorry for taking more time, but
Yeah.
because in my previous organization, they don't want to go with the Snowflake for some of these kind of reason. They went to the Redshift.
Mhm.
So I was not part of the discussion, but I said that, okay, why they took the Redshift? The Snowflake has more capabilities.
Yeah, Snowflake has more capability and easier to manage and it's faster.
Right.
Faster is the biggest one. So it helps consumers to run faster SQL.
Right. So when I asked that, they said that this is the reason why we have to be paid. Okay, so you're doing this.
So I have a bucket. So let me go to S3 AWS. We'll check if the bucket is there. So I'm going to create a stage. So in my demo database, which I created today, I'm going to create a stage. So in the stage, I'm going to mount an external system. So that means I have another AWS account. So this is my another AWS account. So as I said, the account 2. In the account 2, I have a bucket. So in the bucket, there are a lot of data, sir. So there are a lot of data here. So I have a lot of data sitting over there. So I'm going to use this bucket. So I gave a AWS CLI details. We will discuss about AWS CLI tomorrow. So for now, I'm giving some credentials and I'm creating the bucket. I'm creating a stage here. Okay, stage is created. So now I can refresh it.
So it gives all your file information, right?
It
All your
shows all
folders,
my
right?
files. It shows all my
Right.
files. Now Snowflake maintains only the configuration here. This configuration only it maintains. It's not maintaining what my data lake has, what file it has, what the data is stored in my data. That it doesn't store at all. Okay, Snowflake stores only this configuration. The link is created.
Right. It won't store the total
it will
file
not
count,
store
row count,
nothing
like that.
Yeah, it will not store.
Okay, just is kind of a mounting that the folder.
Mounting, you are just
like
mounting it, so you can easily fetch the data and use it. So you are going to fetch the data and load it into your system. For that, you are doing mount.
Okay.
So you are mounting in this case because you have two accounts. Your Snowflake as of now is a different account, right? You are not using the trial version.
Yeah.
So
No, I am
in
using trial version.
Thank you.
So in my trial version, the account is different. So let me go to AWS. You can go to accounts. So if you see my account, this is my account here.
Understood. And your AWS is a different account.
Yeah, different account. So in
Understood.
enterprise also, you will have same. You are not going to have same account. You are not going to use it. So it will be a different account. So this will be a different account. Your data will be there in different account.
Oh, okay.
You will have multiple accounts. So you may use multiple accounts. So this account may be from a different team. They will have another account, like another account. This may be a different team. And this can be Azure also. This can be Azure or Google Cloud. So I can add a stage. I can add a different cloud account. It can be Azure. It can be GCP. So this can be AWS. This Snowflake is running on AWS. But I can add a bucket which belongs to AWS or which belongs to Azure. This can be Azure. This can be AWS. So I can add external containers. The data is there. So this team, let us say this is a sales team. They are having sales data here. And I have finance team who's using Azure. Within the organization, the business group, they are in different cloud account. They are using AWS. They have the data in AWS. So I can create a stage, mount that bucket, start using data from there. I can use financial data. I can take it from Azure. I can mount this bucket and then use this data. So that is how Snowflake is flexible, because it's a centralized data warehouse system. It's flexible enough to connect to different cloud, fetch the data from different system, bring it into your centralized data warehouse layer.
So here the charges will be done for the mounting only.
Yeah, mounting, it's like just like configuration, right? So the charges are going to be less. So here I cannot do analysis. So I have to bring the data. I have to load the data into Snowflake, then only I can do analysis. So if I have to do analysis, then I have to use warehouse. Query analysis, I have to use warehouse. So for doing analysis, you are going to pay. For just creating stage, for creating stage metadata tables, you are not going to be charged.
So then it is like just connecting the link to the different account. Then
Yeah.
what is the use of this stage? Like if I'm not doing any analysis.
So like next we are going to copy the data into table, then only you can do analysis. Okay, so Snowflake has a different warehouse, right? Their compute layer is different. So you have to bring the data into compute layer and then do it. So for that, so you are going to do query processing on the Snowflake layer. So I have to bring all the data close to a Snowflake into the Snowflake storage area, then do the computation. Okay, so you cannot have externally. So if you have externally, you have will bring the data into Snowflake, then do the query processing. So that is how you do it. So you cannot have it in external system and you cannot do it in external. Then you can go for ETL tools. You can use Databricks, Glue for doing that work. Okay, so Snowflake, it's powerful enough in running SQL faster because the architecture is designed such a way that they have a compute layer and the storage layer integrated together. So you have to bring the data into Snowflake, then only you can do computation, query processing. If you have it externally, first you have to copy the data, bring it to Snowflake, then do the query processing. So you are going to do ELT, you are not going to do ETL. So if you want to do it ETL, then you have to do different tools, Databricks or Glue.
So Will, just one question. So stage is just a virtual representation of the data that is residing on the other infrastructure, whether it's S3 or Azure storage, right?
Correct.
So it's not a physical copied stage layer like it happens in Medellin architecture of Databricks.
No. It's not a physical
Okay.
layer. It's just a mounting. We are mounting external system. So and then
Okay.
so now I can copy the data. So now I can copy the data from stage to Snowflake.
Okay. I just wanted to understand the terminology here. Thank you.
Yeah.
Okay, thank you.
Can you
Yeah.
just explain what is time travel and fail safe something?
We are not going to see all this thing now. We'll discuss about time travel, all this thing later. Not now.
Understood.
So so far we have discussed about architecture.
Yeah, just excuse me, just one question more.
Yeah.
Whenever we are saying that we are storing the data, that is indicating the Snowflake storage or AWS S3 storage.
Can you repeat your question?
Yeah, whenever we say that we store the data, then we indicate that we store the data in Snowflake storage or AWS S3 storage.
So always, when we say we are creating table and
We are
loading into
storing
Snowflake.
data, yeah.
So when we create a table and load it into Snowflake, we will say that we are loading into Snowflake. We will not refer about S3. We will not talk about data lake. So we will always say we are loading into Snowflake. So Snowflake storage, even though it's they are using S3, for us X3 is a different system. Okay, so we will
Right.
not consider about. So if it is these external containers, so we have external containers. So S3 is an external system for us where we have the data. Okay. So the internal storage of that we will not consider about.
Okay, internally we are not considering S3 storage, right?
Yeah, so the thing is, we understood the architecture. So we understood the architecture. In the architecture, we have a storage, right? So this we
Right.
cannot access it. So we cannot access this. This cloud account, this S3 storage, we cannot access it. It's proprietary of Snowflake. So they are going to manage it. So we cannot go and modify something in this bucket. We cannot. So even though this S3 storage account is there, this AWS account is our account. We cannot manage this one. So it's managed by Snowflake. So this AWS account is managed by us. So this account is managed by us. This S3 bucket belongs to us. We can manage the data. So from external sources, we bring the data into this bucket. Okay, we don't bring data here directly. So into the system, we don't bring data into this S3 bucket. We bring it here.
No, my question is: suppose you select start from the table name, just insert general record.
Yeah.
Say employee ID, employee name. So where it will be stored in the Snowflake storage or AWS S3 storage?
Snowflake storage. So when you create a table, so you are saying that I'm creating a table here.
Yeah, just simply record. Select start from the table, and table contains a simple record: employee ID, employee name, details, employee details.
Yeah, so when we create a simple table, we store the data. It is getting stored here in the Snowflake. In the Snowflake, so you have a Snowflake architecture. Let me define the architecture. So it has a VM, it has a storage. Okay, so the storage, so when you create a table, it's going to store here in the storage. So this storage, this is a AWS account storage. Okay, it's nothing but a bucket. So this bucket, the data is getting stored permanently here, and I can access this data, I can access this table only through service layer. Through using warehouse, I can access this data. I cannot go directly and access the data. I have to come through service layer using Snowsite or some Snowflake interface.
Yeah.
I can access the data. So is it clear?
Yeah, it is clear now. So from here, whenever we using the multiple times the same query, so every time it will come from the storage of Snowflake, right?
Correct.
Yeah. Then why are we using AWS storage? Is it
so when you are working on enterprise, when you are working on organizations, they have data coming from different sources. Okay, so they have ERP system, they have CRM, so they have different applications. So you collect all the data, so you bring to one system, right? So you have to store it in some places. So you have to bring it to one places, a staging area. So it's like you are storing in one place. That is called the system. So what you do, you bring from external system, you load it here.
Okay, we got it.
Okay, so then I take this data and then load it into Snowflake.
Okay.
I cannot go directly put it here, right? So
Okay,
from
so
external
for
system,
yeah, I got it. So for all the external system, whether the data is coming, everything is coming so we are storing for AWS S3.
correct.
Okay, yeah.
So the data can come from external system into this account or here. So it can be from CSV format, JSON, or different data are coming into your cloud account. So in enterprise, they will have different cloud account. They are not going to have one account for everything, right? They are going to have different accounts. So here, this is a different account and this is a different account. So data is coming.
yeah, ultimately we are storing in the Snowflake storage, not any other storage, right?
You are getting confused with the so you are getting confused with the Snowflake storage here.
Right,
So
right, right.
so the thing is, your AWS has a data lake, as a S3 as a data lake, where I can store any type of data. Okay, it's a general storage layer.
Right, got it.
Like your hard disk, right? You can store any type of data.
Yeah, yeah, got
Okay.
it.
Snowflake is a separate product. So Snowflake is a cloud-based data warehouse. So Snowflake has a storage layer. So you don't have to think about Snowflake is using S3 or Snowflake is using different things. Snowflake is storing internally. And for architecture purpose, we understood that it's using S3 and storing it in S3. But the thing is, you don't have to confuse yourself with comparing with this one, with comparing with this one, with this one. Okay, so both are different things here. So we cannot. So for example, let us say in my organization, I am creating a table. I'm inserting data. So where it will store, it will get stored in Snowflake. Okay,
Right.
it's going to get stored here in Snowflake. So you don't have to think about where it is getting stored. Is it stored in S3? Whether it's stored in, you don't have to confuse yourself. Think that it's getting stored in Snowflake. In the Snowflake storage area, it's getting stored. Whereas you are
Question.
working with CSV file, you are working with JSON file, the data is coming from external systems. The data is going to come into AWS. So these are external interfaces. These are external systems where data is getting stored in enterprise.
Okay. Yeah. Thanks.
And well, the reason behind we are creating this stage is because let's say the external data is in a JSON format, which is a key value pair. Now on JSON format, we cannot write a SQL query. So in that case, this JSON file will be staged into Snowflake storage and will be converted into a structured data on top of which we can write the queries.
Correct. So that is what we are going to do next. So
Okay.
here the data are coming from external system or raw form. Okay, this data are raw form. This data may have a lot of issues. The quality of data will be poor. This data will be in raw form. And here we are creating tables. We are creating data models. So we are creating data models based on our business scenario. We are going to create tables. So data models are nothing but tables. We are creating tables and we are going to take this data, structure it and store it here. Okay, so we are going to take the raw form of data, clean it up and then store it into your Snowflake. So that is what we are going to do. For that we create data pipelines. We do.
Well, so your storage layer on the Snowflake side of it, does it have maximum size?
No, it doesn't have any size because it's
Okay.
using data lake. It's scalable. For data lake, we don't have a limit, so it can scale up easily.
Okay.
So overall in this, right, we are doing a 3 projects, correct? If I understand correctly, three projects, correct?
In the course you are asking about?
Right, in the course, right?
We are doing 2 projects.
Or 2 projects. Okay. When we were going to start that projects, kind of like after how many sessions?
We will take 4 to 5 sessions, then we will start the project.
Okay.
So at present, we are starting into basics. We are learning the
Right.
architecture. So let me take you through the.
Session is completed today for.
So there I see a lot of questions being asked continuously. So I think you can keep yourself like ask all your questions in the chat because like we are deviating from the topics, right? I see a lot of deviations today. So you can ask all your questions in the chat because I see a lot of questions are coming in different topic. When I'm talking about architecture, I'm getting question on versioning. I'm getting questions on different things, right? Just deviating us completely. So you stick to the topic. If you have questions, you can always use chat. I informed in the last session also. So use chat, ask your questions. If you keep asking a lot of questions, if you interfere, then I'm going to get deviated. So I see today a lot of deviations happen today. So at present, we are not in the track. So in the next session, try to ask all your questions. which are limited to the topic. So we are discussing about architecture today, and we are discussing about the basic thing today. Okay, so we have not started on the other things. We will. So if you see the sections here, so this is how we are going to go. So we will start with OLAP operations tomorrow, how to create Snowflake tables, how to create, then cloud integration, how to work with the cloud integration, then data sharing. Then we will get into how we can do ingestion, then how to use Airflow. Then only we can start project. Okay, so if you don't know all this thing, straight away we cannot get into project. Okay, so you can see class 11, we are starting project. Before starting project, you need to know how to use Airflow, how to create tables, how to do ingestion, how to do cloud integration. So without knowing this, we cannot start project. Okay, so
Right. Yeah, that's the reason I'm asking. Kind of like these sessions will be every week, like on Friday, Saturday, and Sunday, 2 hours, or it will be
yeah,
more than
Saturday,
that.
Sunday, 2 hours.
Okay.
So we will stick to the topic. So if you see here, projects we are going to complete start by 11. So it's not that even though we are starting on a project on 11th, but if you don't know all this thing, right, we cannot
Yeah, it
start the
doesn't make
project.
sense. Yeah.
Okay, this all this thing are
Uh,
essential.
well, I don't think we are deviating. Most of the questions we ask are relevant to the topics, and we are looking at module number 2. If I'm looking at the syllable, the course syllables, the only thing we did not cover today is users,
No,
roles, and
what I was
privileges.
saying, deviating from topic is
Yeah, sir. To avoid this deviating from the topic, maybe
no.
what
The thing
we
is
are-
like, can you listen for a few minutes? I'll tell you. Then so if think that you are going to watch the recording tomorrow. So watch the recording of today's session. You will understand what is the deviation. So I am starting with architecture. I am going through few sections. I'm going to complete everything. Then you can ask questions. So it is easier for me to answer to relevant to the sessions. So if in between, if you start asking questions, right? So if I'm going to answer you, then I'm going to continue. There will be no continuity. There is no continuity. So it will be when someone is going to watch the video, if you are yourself, you are going to watch the video, it will not be easier for you to understand the topic because in between there will be questions and answers and there will be no continuity. So like if you are asking questions at last 15 minutes or if you're asking in chat, it will be easier for everyone. It will be easier for us to like discuss about the particular topic and complete it. Then you can ask your question in last 15 minutes.
Okay. So last 15
Okay.
minutes makes sense.
Yeah.
Okay.
Makes sense. Yeah.
Thank
Thank you.
Okay, you can put it on the chat. I'll answer it if it is related to chat, if it is relevant to the current session. Or if you want all the questions, different questions. If you have different questions, you can ask in the last 15 minutes. We'll cover all the questions in the last 15 minutes. So it's easier. We'll have continuity on all the topics. So it will be easier for you to watch the recording.
So our class is 2 hours or how many hours? So we know
2 hours.
you know towards
2 hours.
2 hours. So it's 8:30 IST to
Yeah.
10:30.
10:30. Yeah.
Okay, thanks.
Okay. So far we discussed about architecture. So we have started on architecture and then I ran a few basic query. So I created a database. I created a schema and then I created a table. Okay. So next thing, the important thing we want to do is, so like normally in my local, I'll show my local environment. So local setup, I have Visual Studio Code. Okay, so I have Visual Studio Code, IDE for faster development. Okay, so faster development. And also, let me open Visual Studio Code. So we can see here. So we have organized. So day 1, day 2, day 3, like that you can see. So whatever I'm teaching. So for example, day 2, let us open day 2. So whatever I taught today. So if you can see creating table, inserting data, selecting something. So we are then creating roles. So we have done this one. So we have done this one so far. So you can see I have it in SQL. So I have all the SQL. So in your web UI, if you have it in web UI, you can use workspace. So this problem is it is not easier to have it for longer time. Okay, so for development purpose, referring it multiple notebooks, it's not easy to, but here I can refer it easily. So for example, if I open the entire folder, so I can refer previous day, I can refer the different days. So I'm organizing it in better way. So if you use Visual Studio, it will make your development easier and you can refer previous sessions and you can organize things in easier way. So you can also have Visual Studio in local, and in Visual Studio, you can go to extensions. So for installation of Visual Studio, I'll share the setup. So you can see the Visual Studio setup. So you can download Visual Studio and you can have locally installed Python and AWS CLI. So we need AWS CLI. So we'll discuss about why AWS CLI, all this thing later. So we are going to have Visual Studio first. And my local, I have Visual Studio installed already, and I can see my notebooks. In Visual Studio, you have extensions. You can go for extensions. And here you can search for Snowflake. And you can see the extension provided by Snowflake. You can enable this, you can install it. So you will get Snowflake option here. Okay, you will get Snowflake option. So I can start connecting Snowflake from my local itself. So I can execute here itself. I can run my queries here itself. So I don't have to go to web UI, run my queries there. So you can use web UI also, but for development, for better practice, for referring previous projects, to work as a project. When you're working on project, you have multiple files. This is easier to develop things. So this is how you can maintain it. So let me run it. We'll go to the day 2. So if I run it now, if I execute it, so I can run the entire, all the notebook. I can run only one part. So if I execute it, it's asking for password. So I can go and configure my account. So here I can sign up with a different account. So I can give my account URL. So how you will get this information? So it's asking for account identifier. It's asking for account information. I can go to my Snowflake. Go to your account. You can see view account details. You can copy the account URL, paste it here, you continue. Last for the username. So I'll give the password, then sign up. Okay, so from my Visual Studio, I am able to connect to Snowflake. Okay, so you can see now, I can see the database. I can see all the database. So we were using demo. You can see demo database here. I can see the demo schema. Okay, I can run queries here. You can execute it. Okay, so here you can use Visual Studio Editor for code development, and you can organize it in better way. So we were going to use this, like, okay, so I may use both. I may use for few of the things. I may use workspace. I'll use this workspace for writing the code, SQL, creating tables. For a few of the things, I'm going to use Visual Studio Code. So in your local, you need to set up few softwares. So I'm going to share this one, local setup environment. So you can start installing it and start configuring it. So you need Python. We need Docker desktop. So we need DB viewer. So like different softwares are required in local. Okay, so we need to install all these things. So Visual Studio Code is the first one. So AWS CLI is required because we are going to use Airflow. When we are going to use Airflow, we want AWS CLI, we want Docker, and we want Python. So for the Airflow, the softwares are required. So you can install it initially, or you can install it later also. When we are going to start Airflow, all these things are required. Okay, so my local setup, this is how my local setup is going to be. So you can start setting up your local. So initially, you need to have your AWS account. So you should have AWS account. So we can work on integration of your data lake. So you should have your Snowflake account. Then you should have your local setup. So this is going to help us for working on Airflow, for working on our projects. This environment is going to help us. I'll share this link.
Thank you. Thank you. Can we stop here, please? I'm feeling sleepy now.
Yeah. I'm going to stop it. So
and I wanted to say something, if you don't mind. Our free account, is it valid for only 30 days or something? So the earlier we start practicals, the better, so we don't waste our credit.
Yeah, so normally when you use your warehouse, you are going to like use small warehouse, use like a small, don't go for large, medium, use small warehouse. And also it will get suspended automatically. Okay, so you can see this warehouse option. You can, when you create normally by default, this warehouse will be created and you will see an option here, auto suspend. So that you can it will be automatically enabled for you. So if you are not using it, your warehouse will suspend. So your credits will not be lost. Okay, so you can see this option is enabled for you. So it is by default enabled. So your warehouse will be suspended automatically.
Okay, thank you.
Yeah.
Okay, so we will stop it for today. We will connect again tomorrow. So I will share the Notion link. I will share the content, whatever we discussed today. So everything will be shared today. I'll share the video in the WhatsApp group today.
Thank
So
you.
any questions from
Thank
anyone?
you.
Okay, fine. We'll connect again tomorrow. Thanks, everyone.
Thanks, everyone.
Thank you.
Thank you.
Bye.
Bye.
Thank you. Bye.
He will